All right, let's unpack this. If you're knee-deep in DevOps and continuous delivery, there's one area that can still give even the most seasoned engineers, well, a knot in their stomach, database migrations. Unlike your application code where, you can often just roll back to a previous commit, with a database, you can't exactly hit undo after a schema change goes sideways.
Not easily, no.
So today, our deep dive is all about tackling that high-stakes challenge. We're going to explore how to make those database migrations truly bulletproof by integrating Kubernetes with Flyway.
Right.
Our mission here is to pull out the most important nuggets from our source material, kind of give you a shortcut to getting a handle on this really critical, yet, let's face it, often terrifying, part of your deployment pipeline.
And that feeling of terror is precisely what we want to help folks move away from. What truly stands out about the approach we're discussing is how much control we can actually gain over what seems like an inherently daunting process. Database reliability in production isn't just a nice to have, it's absolutely non-negotiable. The consequences of a failed migration can be severe. I mean, from hours of downtime to potentially irreversible data loss. So our goal here is really to help you shift from that anxiety to, genuine confidence when it comes to evolving your database schema safely.
So let's lean into that anxiety just a bit. Why exactly are failed database migrations in production considered one of the sort of highest risk scenarios in modern DevOps? What happens, practically speaking, when a schema gets left in an inconsistent state? I've personally been in that war room scenario where migration went sideways and it felt like the world was ending. It's truly one of those moments where you give anything for a magic undo button. Is that the kind of stomach-churning scenario we're fundamentally trying to get rid of with this approach?
Absolutely. And your experience isn't unique, unfortunately. That feeling is universal because the stakes are just so high. The difference from application code is stark. If your new app version crashes, okay, you can often quickly revert to the old one and you're back, mostly. But with a database, if a migration fails midway, it can leave your schema corrupted, unusable, or just inconsistent. And fixing that isn't a simple revert. It often means hours of manual recovery work by a senior DBA, or, worst case, a full restoration from your last reliable backup.
Which implies potential data loss.
Exactly. Depending on your recovery point objective, that's, how much data you're willing to lose in a disaster. So this raises a really important question. What's Flyway's fundamental limitation that makes this so challenging on its own? Why do we need these extra layers?
Okay, what's the core Flyway issue here?
Well, Flyway on its own is fantastic for forward migration. It tracks your schema versions, applies new changes systematically. You always know which scripts have run. Great stuff. However, its built-in functionality does not include automatic rollback for data definition language, DDL operations, and this is especially critical for non-transactional databases like, say, MySQL or MariaDB. In those systems, DDL changes, think create table or alter column, they're immediately committed as soon as the statement executes. They don't participate in a larger transaction that you could just roll back if something later fails.
So if one part works and the next fails, you're stuck halfway.
Precisely. If an alter table fails halfway through in MySQL, those partial changes are still there committed. You're left with a broken schema and a very complex manual cleanup job.
Wow, okay. That distinction between transactional and non-transactional DDL is huge. So knowing that limitation, how do we actually build this robust defense-in-depth system around Flyway? The source material talks about this Kubernetes native control architecture. Can you walk us through the philosophy and the key pieces?
Yeah, absolutely. The core idea isn't just about tools. It's about building layers of safety, a defense in depth around your migrations. Treat them with the same rigor you treat your critical app deployments.
Makes sense.
So to get this bulletproof system, we layer several components within Kubernetes. First up, Helm pre-hooks. These are really clever job annotations like pre-install and pre-upgrade.
Right, they run before the app deployment.
Exactly. They orchestrate the migration before your application deployment even starts. Second, the Flyway jobs themselves. They're containerized in Kubernetes and crucially designed with retry policies for resilience.
Okay.
Third, backup automation. This is non-negotiable. You need robust point-in-time recovery capabilities, usually through database snapshot jobs with clear retention policies.
Got it. Backup first.
Then fourth, and this is a real game changer, rollback scripts. This means automated schema reversion through paired migration files that have explicit undo operations. We'll dig into that.
The undo logic.
Okay. And finally, state validation. This involves things like health checks and maybe even schema validation after the migration runs, but before the app connects, to verify everything actually succeeded.
That layered approach makes a lot of sense. So for listeners trying to picture this, what does this architecture actually look like in practice? Can you walk us through how a Helm chart migration job might be set up?
Sure. So the Helm chart migration job is basically a standard Kubernetes job resource, but it's got some crucial metadata and structure.
Okay.
You'll see annotations like helm.shook, pre-upgrade, pre-install. That tells Helm, hey, run this job before doing an upgrade or the initial install.
Right.
Then you might see helm.shook wait, negus 2. That wait just ensures it runs early in the hook process before other hooks, perhaps.
Ordering.
Yeah, and also helm.shook delete policy. Before hook creation, hook succeeded. This is neat. It automatically cleans up the old job instances so your cluster doesn't get cluttered.
Nice housekeeping.
Exactly. Now, structure-wise, the job usually has init containers and then the main containers. A key example from our source is a database backup init container.
What does that do?
It might use a standard image like postgres.55 and runs a script, say backupscenes.esh. Its whole purpose is to take a quick pre-migration schema-only backup.
Schema only, so it's fast.
Much faster than a full data backup, yeah. Gives you a rapid fallback point. Then the main Flyway container takes over. It uses a Flyway image, obviously, and runs a custom script, maybe called migration with rollback.esh.
Okay.
And the real magic, the safety net, is orchestrated within that script.
Right. That custom script sounds key. So what's the core logic inside migration without rollback.esh that makes it bulletproof? Especially around handling errors, you mentioned a trap mechanism.
Yes, that trap mechanism is a really elegant piece of shell scripting for proactive error recovery. The script itself should start with set UO pipe fail.
Which does what again?
It makes the script exit immediately if any command fails, or if it tries to use an unset variable, or if a command in a pipeline fails. Basically, fail fast, fail safe.
Got it. Crucial.
Then the core error handling is often a line like, trap rollback required true, executor rollback, exit 1, error.
Okay, break that down.
It tells the shell, if any command in this script exits with an error, a non-zero status, immediately set this variable rollback required to true, then call this function named execute rollback, and then exit the whole script with a failure status code 1.
So any error triggers the rollback function automatically.
Exactly. It guarantees that if the Flyway migration command fails, or even some other setup step in the script fails, the rollback procedure kicks in reliably.
And what's inside that execute a rollback function? What steps does it take?
It's designed as a multi-step safety net. First, it usually runs Flyway repair. This is vital because a failed migration can leave junk in Flyway's history table, the Flyway schema history table.
Why, it gets confused.
Yeah, so Flyway repair cleans up those failed entries, which lets you potentially rerun a corrected migration later without manual fiddling.
Okay, step 1, repair Flyway's state.
Step 2, it attempts to execute any custom rollback.sql scripts if they exist. These are the explicit undo scripts we talked about, the paired U files.
The manual undo for specific changes. Got it.
Step 3, and this is sort of the ultimate fallback, if that schema backup.sql file was created by the init container.
The fast schema backup from earlier?
Right. If that exists, it restores the database from that backup, maybe using PSQL or MySQL command line tools. This gets you back to a known good state before the migration even started.
The full reset if needed.
Exactly. And finally, the script should have a critical validation check at the end. It compares the current version reported by Flyway info with the expected version based on the files it tried to apply. If they don't match, something went wrong, even if no specific error was thrown, so it exits with an error.
Wow, that's incredibly thorough. Okay, you mentioned earlier the difference between transactional and non-transactional databases again.
Correct.
How does that specifically impact the rollback strategy? Why is that difference so fundamental here?
It's a game changer for how you plan your undo steps. For databases like PostgreSQL, DDL operations are transactional. Meaning you can wrap your create table, alter column, whatever, inside a begin commit block. If any statement inside that block fails, the database itself automatically rolls back the entire transaction.
So the database handles the undo internally.
Exactly. It leaves your schema in its original state before that migration file started. It's a fantastic built-in safety feature.
But not all databases do that.
Right. With databases like MySQL or MariaDB, DDL is typically non-transactional. Each create table or alter statement is immediately committed. Bam, it's done.
So no take-back Cs from the database itself.
Pretty much. If an alter table adds a column, that change is instant. If the next statement in your script fails, well, that column is still there, you added it. And that's why you need explicit drop table if exists, or similar cleanup commands in dedicated rollback scripts, because the database simply won't do it for you.
Okay, so given those challenges, especially with the non-transactional ones, how do we explicitly build that undo capability right into our migration process? Is there a recommended pattern for that?
Yes, absolutely. That's where the paired migration pattern comes in. It directly addresses this non-transactional DDL headache by making sure you have a predefined undo path for every single forward step.
How does that work structurally?
You basically organize your migration scripts into two distinct directories. Let's say Flyway Squirrel and Flyway Rollback.
Okay.
The Flyway Squirrel directory holds your standard V for versioned migration files like v1 bot1 adducertable.sql,
Right.
standard Flyway stuff.
Right.
But then for every V file that makes a DDL change, you create a corresponding U for undo script in the Flyway rollback directory. So you'd have u1.1.adducertable.sql to match the v1.1 file.
So V does the work, U undoes the work.
Exactly. Think of it like a checklist. For every action, you have a pre-planned reverse action. This ensures that for every forward migration step, there's a precise, automated way to revert that specific change if things go wrong. You're not just relying on hoping the schema backup restores cleanly.
That makes so much sense. Building the undo right alongside the do. Okay, so we've got robust rollback logic, explicit undo paths. But what about those foundations, backup and repair? How do those supporting pillars integrate to make the safety net even stronger?
Yeah, they're fundamental. Automated backups are your absolute first line of defense, always. The source describes an automated backup integration job. This also uses a Helm pre-upgrade hook, but remember the hook weights. This one gets a higher priority, like hook weight, -3.
So it runs even earlier, before the migration job itself.
Precisely. It guarantees you have a fresh backup before any changes are even attempted by the main Flyway job. And its purpose, as we mentioned, is often to do that fast schema-only PG dump.
Right, for quick restores.
Quick restores, exactly. It might also store some metadata about this backup timestamp, file name somewhere accessible, so the rollback script knows which backup to potentially use.
Smart. And the Flyway repair automation.
Right, Flyway repair automation. This is usually achieved by setting a simple flag in your flyway.conf configuration file. Flyway.repair on migrate true.
Okay, what does that flag do?
When it's enabled, Flyway will automatically remove any failed migration entries from its internal history table, Flyway schema history, before it attempts to run migrations.
So it cleans up after previous failures automatically.
Yes. This is super important because if an entry for a failed migration script, say v1.2, remains in that table, Flyway might block you from re-executing a corrected version of v1.2. By setting this flag, Flyway cleans it up first, letting you fix your script and just rerun the migration job without needing a BBA to manually delete rows from the history table.
Streamlines the recovery significantly.
Huge time saver, reduces manual error potential.
Okay, so with all these layers, the hooks, the backups, the paired rollbacks, the repair, how do we actually know in production that our migrations are truly bulletproof?
Yeah.
What are the key metrics, the monitoring we need to have in place for that real-time confidence?
Yeah, trust but verify, right. Production monitoring and observability are absolutely non-negotiable here. You must integrate tools like Prometheus, probably using a service monitor in Kubernetes, to scrape metrics directly from your migration jobs.
And what metrics are we looking for?
Several key ones. Migration duration is crucial. You need to baseline how long migrations normally take, and then watch current execution times. If they spike, something might be wrong, or you have a performance regression.
Okay, duration. What else?
Obviously, failure rate. How often are these jobs actually failing and triggering a rollback? You want that near zero.
Naturally.
And conversely, rollback success rate. When a rollback is triggered, does it actually succeed? You need to measure the effectiveness of your safety net.
Good point. Is the safety net actually working?
Right. And perhaps most importantly, for long-term database health, schema drift detection. You need ways to detect if the schema in production somehow deviates from what's defined in your Git repo or expected by Flyway. This catches manual hotfixes or configuration errors that could cause massive problems later.
Schema drift, yeah, that's a sneaky one. Okay, metrics are great, but what about immediate alerts?
Absolutely critical. You need a robust alerting strategy. Using something like a Prometheus rule, you define an alert, let's call it Flyway migration failed. This alert should trigger immediately if the cube job status failed metric for any job matching your migration job pattern, like Gotcha's migration, goes above 0.
So instant notification on any failure.
Instant notification sent to your on-call, PagerDuty, Slack, whatever. And this alert absolutely must be linked to clear, documented run vitals explaining exactly how to respond, even if the automated rollback worked. You want eyes on it immediately. No guessing during an incident.
Right. Clear action plan. Okay, this sounds really solid for a single application, single database. But what about larger, more complex enterprise environments? Are there advanced patterns that take this even further?
Yes, definitely. For larger scale, you start looking at things like multi-environment migration gates. This isn't just running migrations in one staging environment.
More stages.
Often, yes, but more importantly, it involves validating migrations across several representative environments. And crucially, running comprehensive application compatibility checks in those stages. Does the application still work correctly with the new schema?
Testing the whole stack, not just the DB change.
Exactly. And here's a key practice. Before deploying to production, you might actually roll back staging after a successful test.
Rollback staging, why?
To ensure it's a completely clean slate for the next deployment's migration test, it makes your staging environment a true, repeatable proving ground for the entire migration and rollback process every single time.
Interesting. Verifying the rollback works, too.
Yeah.
Okay, what else?
Another really powerful pattern, especially for minimizing downtime, is blue-green database migration.
Okay, I've heard of blue-green for applications. How does it work for databases?
The concept is similar. Instead of migrating your live blue production database in place, you first clone the production database. For example, in Postgres, you might use create database dbName green as template bname blue.
So you get an identical copy.
An identical copy at that point in time. This new copy is your green database. You then run all your migrations against this clone, the green database, completely isolated from live traffic.
Okay, migrate the offline copy.
Right. Once the green database is fully migrated and passes all validation checks, schema checks, maybe even some smoke tests with a test instance of your app, then you switch the application traffic.
You point the apps to the newly migrated green database.
Exactly. The green database becomes the new blue. This minimizes downtime dramatically because the migration itself happens offline relative to user traffic. The cutover is usually much faster than the migration itself.
That blue-green approach sounds amazing for zero downtime goals, but I imagine it's not trivial. What are some of the practical challenges or trade-offs you run into there?
You're right. It's powerful, but definitely has complexities. The biggest hurdle is often handling data synchronization during that cutover period.
Right. While you're migrating the green copy, the blue one is still taking writes.
Exactly. So if your application is writing data to the old blue database while you're busy migrating the green one, you need a solid strategy to capture those changes that happen during the migration window and apply them to the new green database before you switch traffic.
How do you do that?
That often involves tools for logical replication or more advanced CDC change data capture mechanisms. These tools stream changes from blue to green. It adds complexity to the setup.
Okay, data sync is hard. What else?
Resources. You need essentially double the database resources, storage, potentially compute, for the duration of the blue-green process, which can be a significant cost consideration.
Good point. Double the infrastructure.
And finally, the application itself needs to be designed to handle the switch gracefully. This might involve coordinating service restarts or having sophisticated connection pooling that can be redirected smoothly. It's definitely a bigger architectural investment.
Makes sense. Powerful, but requires planning and resources. Okay, zooming out a bit, how does this whole robust migration framework, the hooks, rollbacks, blue-green, potentially fit into the bigger picture of disaster recovery and business continuity? Seems like it'd be a foundational piece.
Oh, absolutely integral. Having reliable migrations and rollbacks makes your point-in-time recovery integration much more effective and less scary.
How so?
Well, imagine a bad migration does somehow cause data corruption despite all the guards. Because you have version migrations and potentially backups tied to specific pre-migration points, you can use tools like progress-store startbat to restore your database to a very precise timestamp just before the problematic migration started.
Okay, restore to the moment before disaster.
Right. And then, because you know which migrations are good up to that point, thanks to Flyway, you can reliably apply known good migrations to bring the database forward again, but stopping before the faulty one. It turns a potential multi-hour crisis into a much more controlled recovery procedure.
That's a huge difference.
It really is. And for companies operating globally, multi-region rollback coordination becomes a factor.
Handling rollbacks across different data centers.
Exactly. If a bad migration gets deployed everywhere, you need to roll it back everywhere consistently. The source mentions using a coordinated job, maybe a central Kubernetes job that triggers and monitors rollback jobs in each geographic region.
Like running kubectl against different cluster contexts.
Yeah, something like two-vector context, region context, create job rollback region executed for each region, with the central job waiting for all of them to complete successfully. It ensures that your recovery is harmonized globally, minimizing inconsistent states across regions.
Orchestrating recovery on a global scale. Wow. Okay, this is all fantastic. For listeners thinking, okay, I need this, what's a realistic timeline to implement something like this? And maybe more importantly for their managers, what's the real ROI?
Good questions. The suggested implementation timeline is actually pretty practical, broken down iteratively.
Okay.
You'd likely spend week 1-2 focusing on the foundation setup. That means containerizing Flyway with those basic custom rollback scripts, getting the Helm hooks working for job orchestration, setting up essential backup automation with retention, and putting basic monitoring and alerting in place. Get the core mechanics working.
Right. Start with the basics.
Then, in week 3-4, you start layering on the advanced features. This is where you develop those paired V and U migration patterns for your specific schema changes, implement the automatic Flyway repair configuration, add more comprehensive schema validation and maybe drift detection, and start building out and testing your disaster recovery procedures based on this framework.
So roughly a month to get a pretty robust system in place.
To get a really solid V1, yeah. It's iterative, you'll refine it, but you start seeing benefits very quickly, especially reduced anxiety around deployments.
And how do you know when you're really production ready? Is there a checklist?
Absolutely. A good production readiness checklist would include things like regularly verifying your backups by actually performing test restores. Don't just assume they work.
Test the restores, yes.
Conducting end-to-end rollback testing and staging before every production release that includes a migration. Ensure your full monitoring stack covers the migration jobs comprehensively. Metrics, logs, alerts. Having crystal clear, easily accessible runbook documentation for handling any potential migration failure scenario, even if it's automated.
Yeah.
And if you're multi-region conducting cross-region coordination tests, you don't want the first time you test global rollback to be during a real incident.
Build it, verify it, document it, test it.
You got it.
So let's talk bottom line. What does this all mean for a business investing the time and effort? What's the tangible ROI? The ROI and business impact can be really significant. Let's talk risk mitigation first. Your recovery time objective, or RTO, how fast you can recover from a failure, can plummet. We're talking potentially going from 4+ hours of manual panic database recovery down to maybe 15 minutes or less for an automated rollback.
Wow, hours to minutes.
Huge difference.
Yeah.
The goal is zero production data loss incidents related to migrations. You should see a massive drop, like a 95% reduction in deployment rollbacks caused by migration failures, and significantly less need for DBAs to manually intervene, maybe an 80% reduction in DBA intervention requirements for routine migrations.
That frees up DBAs for more strategic work, too.
Absolutely. It reduces stress, cost, and developer friction enormously.
What about success metrics? What should teams aim for? Key success indicators to target would be something like a 99.5% first attempt success rate for migrations going into production. When rollbacks do happen, they should be automated and complete within 5 minutes. You should aim for zero schema drift detected between your environments. And crucially, no block deployments waiting on risky or slow migration processes.
So it really unblocks the pipeline.
That's the strategic outcome. You transform database migrations from this high-risk, dreaded bottleneck into just another reliable, automated part of your CI/CD pipeline. It enables true continuous deployment, letting you deliver value faster while maintaining complete data integrity and aiming for zero-downtime operations.
It's not just protecting data. It sounds like it's fundamentally about unlocking team confidence and agility.
That's it, exactly. It changes how teams approach change.
What an incredible journey today. We really went from that high-risk, anxious reality of database migrations and walk all the way through constructing this, well, truly bulletproof automated solution using Kubernetes, Flyway, and just layers of smart strategies. It really builds confidence into every release, doesn't it?
It really does. It's about building that confidence and resilience right into your deployment pipeline, turning a major source of anxiety into a well-oiled, predictable, frankly, less boring process because it just works. It empowers your teams.
So as you're listening, consider how these layered defenses don't just protect your data, though that's critical, but how they could fundamentally change your own team's confidence and agility. What hidden bottlenecks, what sources of friction in your current deployment pipeline could maybe be transformed by applying a similar layered automated approach? Something to think about. Thank you so much for joining us on this deep dive.